Okay, in this video we'll complete the last few homework exercises in Chapter 4, Section 1. And number 30, we want to model with mathematics. A recording studio charges musicians an initial fee of $50 to record an album. Studio time costs an additional $75 per hour. So what we want to do is to write a linear model that represents the total cost of recording an album as a function of studio time in hours. Well, actually, this is a very similar word problem to the types of word problems we were working with way back in Chapter 1. You have an initial fee and then you have a recurring fee. So if we were to make a table and to look at for how many hours we use the recording studio and what the cost was, we might see that for 0 hours we have an initial fee of $50 regardless of how much we use or how much actual recording we do. We're going to have to pay $50 to reserve the studio. And then after that, each additional hour is $75. So for 1 hour, the cost will not be $75. It'll be $75 for the hour plus the $50, which would be $125. For 2 hours, it would be $125, an additional $75 for $200. Now what you should start to notice here is that this is going up by 75 each time. Each time the hours goes up by 1, the cost goes up by 75, and that is the slope. So that's a very powerful idea there, and when we write our function, it would be y is equal to 75x plus 50. So that is the linear model. That represents the total cost of recording an album as a function of studio time in hours. Now, the question in Part B is it less expensive to purchase 12 hours of recording time at the studio or a $750 music software program that you can use to record on your own computer? So the first thing that we want to do here then is to actually figure out what would the cost be for 12 hours. In that case, x would be 12, and we're simply going to, this turns out to be 900, that's plus 50, or $950 if we were to use the recording studio for 12 hours. So is it cheaper? It is definitely cheaper to buy the software program. So we say that it would be cheaper to buy the program for $750 since studio time would cost $950. And so that's really all there is to this. This is a similar problem to one we worked with before, only here it's open-ended. It's a model. It will tell us how much it will cost for any number of hours, and we're going to plug in the number of hours, that is the value of x, and we're going to get back from this model how much it would cost us to record for that number of hours. All right, we'll go on to the final example in this section, and that is problem number 36. How do you see it? The graph shows the approximate U.S. box office revenues. What does box office revenues mean? That means the money brought in at movie theaters, box offices, movie theaters, in billions of dollars from 2000 to 2012, where x equals 0 represents the year 2000. So x equals 0 is 2000, then 2 is 2002, 4 would be 2004, etc. Now if we look along our y-axis, we're going up by $2 billion each time for each line on the grid there. So it appears that we're starting off at $2 billion in 2002. So if we make a table, year, not $2 billion, revenues would be $8 billion, sorry. revenue 8 billion in the year 2000. So instead of using the year 2000 though, we're simply going to use the number 0. And the first thing we want to do is to estimate the slope and the y-intercept. Well, it appears that the y-intercept is 8. Because that's the y value when x is equal to 0. Now if you notice, we don't have a good point here to use, but each grid line goes up by $2 billion. So we might want to try, if this were halfway, that would be roughly 9 billion. And it appears that we're about half of that. So this point on the graph here might be 2 and not 9, but 8.5. So we'll add that. That would be the year 2002 and 8.5 billion. So we're not going to use the year, we'll use the 2. And from this point we can calculate our slope. We have our x1, y1, x2, y2, m is equal to y2 minus y1 over x2 minus x1. And we would have 8.5 minus 8 over 2 minus 0, and that would be a half over 2, roughly, or that would be about 0.25 for our slope. And our y-intercept is 8, so our model would look something like y is equal to 0.25x plus 8. And that indicates, what does the 0.25 mean? So now we want to interpret revenues are increasing at a rate of $0.25 billion a year. $0.25 billion, a quarter of $1 billion would be $250 million. Alright, so the next thing then is, how can you use your answers in Part A to predict the box office revenue in 2018? Now also the 8 billion, we needed to interpret that. The 8 billion is the revenue in the year 2000. Right. So we've interpreted both the slope and the y-intercept. Now how would we use this to predict the box office revenue in 2018? Well, 2018 would be 18 years from 2000, and so we would use y is equal to 0.25 times 18 plus 8, and using our calculator, if we can do this correctly this time, it would be 0.25 times 18, then plus 8 would be about 12.5, and that might make sense if we look at our graph. At 12 we're over 10 billion, so at 18 we would likely be above 12 billion. Alright, so you want to look at these last two examples that we've done. The previous one didn't require us to calculate the slope. It actually told us that for each additional hour there would be a $75 charge. So that's a way of telling us what the slope is, whereas in this case we had to actually calculate by estimation what the slope was. But however, we would use those two linear models in much the same way, plugging in some value further down to estimate what the underlying function, the value of the underlying function would be at that point. Alright, so we're going to stop this video, and that concludes the video series for this section.